Welcome to the part 2 of array implementation of stacks. In this presentation, we will see the actual C code for implementing the push operation, not the pop operation. In the previous presentation, we have seen some basics related to push and pop operations. How to perform push operation and how to perform pop operation, right? In this presentation, we will actually see the code for implementing the push operation of stacks. So without any further delay, let's get started. Now we will see one program which helps us in pushing an element onto stack. Here we know this is an array, right? This is a stack ARR, which means this is an array representing a stack. In future, we will have functions for different operations, including push and pop. Isn't that so? This is very true. We will have functions for different type of operations that we want to perform on stack, right? So we will have functions for different operations, including push and pop. Almost every function requires the stack ARR array. Almost every function requires this array, stack ARR, in order to perform operations on it, right? Instead of passing it to every function, the better option is to declare the stack ARR globally. This is my call, okay? Instead of passing it to every function, instead of passing this stack ARR to every function, the better option is to declare this array, the stack ARR globally. Isn't that so? This means we need a global declaration of this array so that every possible function in that particular program can access this particular array, right? So here is how it looks like. This is the global declaration of stack ARR array, isn't that so? You can see I have written hash include stdio.h. After this, I have written this line of code that is int stack ARR, and obviously within the square brackets, I have written 4, which indicates the size of this array, the capacity of this array. And after this, we have this main function. It simply indicates that this is nothing but a global declaration of stack ARR, right? Now you can see that I have declared the size of this array or the capacity of this array in this way. Actually, there is a better way of doing this. We can also use a hash defined preprocessor directive to declare this constant. And this is how it looks like. Hash define max4. Okay. I have chosen this name. You can choose any name. That is up to you. This indicates this maximum size of the array. Okay. Right now we want that the maximum size of the array must be 4. That's why I have written this line of code that is hash define max4. Now instead of writing 4, we can write max. So max is actually indicating 4. This particular constant. So here we can replace 4 by max. This is the same thing. Actually, this is nothing but int stack ARR 4, right? Similarly, top variable is used multiple times in different functions. Isn't that so? This variable top is also used multiple times in different functions. There's no doubt about this. Instead of passing it to every function, the better option is to declare the top variable globally, as this top variable will be used multiple times in different functions. Therefore, it is important to declare it globally, right? That means we need a global declaration of this variable. And this is how it looks like. This is the global declaration of variable top, and currently you can see it is holding -1, which indicates that the stack is empty. Currently, the stack is empty, okay? Top equal to -1 indicates that the stack is empty. We are already aware about this, right? Now we are interested in pushing the element 1 onto the stack. Obviously, we are interested in pushing this element. That's why I have written push 1. Okay. This means I have to create a separate function, right? A function which can push an element onto the stack. Recall that pushing an element involves 2 steps. First, increment the variable top by 1. We first have to increment the variable top, right? You can see variable top is holding -1 currently. -1 is not a valid index. It is important that we must increment the variable top by 1. Then after this, we can store the value at the index top. Simple. This is how push function looks like. Currently, it is not holding anything. I have not defined this function. You can see that the return type of this function is void because I don't want to return anything from this push function, right? And here in this push function, you can see in the parameter list, we have just one parameter, that is int data. Obviously, we are passing some value to this function and we need some variable here to store that value. That's why I have written int data over here. So we can see that we have this data variable, and in this data variable, we have this value 1, right? After this, we'll need this line of code that is top equal to top plus 1. That means incrementing the value of top by 1, right? You can see that top is currently holding this value -1. Obviously, you can see the global declaration of this top. This function can access this top variable because this top variable is declared globally, right? There is no need to pass this top to this push function. That's why I've told you it is easier to declare the top variable globally, right? So that every function can access it. So I've declared this variable top over here, and you can see that this push function is actually accessing this variable and it works. Here, I'm incrementing the value of top by 1, which means that this value will get replaced by 0 and everyone can see it, right? After this, we need this line of code to store data in stack ARR top, which means we will store value 1 at index 0. Isn't that so? This is what we are trying to do. Stack ARR top. We know that top is 0, so we can replace this by 0. Stack ARR 0 means this cell. So actually we are trying to store this value in this particular memory cell, right? That's it. This is all what we need. Okay. Let's say we are interested in pushing this element too. In that case, obviously, this variable data will receive this value too. After this, we have this top equal to top plus 1, which means that top will get incremented by 1. And after this, we are using this line of code to put this value inside this memory cell, right? So after this step, 2 will get stored over here. Isn't that simple? I hope the idea is clear to you. After this, we are interested in pushing this element 3. Again, this data variable will receive that value, and then we can simply increment the top by 1 and we can store this value in this particular memory cell. Obviously with the help of this line of code, right? And then we are interested in pushing this particular element. Again, data variable will receive this value 4, and after this we can increment the top by 1. Okay, this means that this will get replaced by 3, and after this we'll simply put this value at this particular memory cell. Okay, simple. Now we are interested in pushing this particular element, but wait, the stack is full. You can see that the stack is full. The capacity of the stack is 4, which means that it can hold 4 elements at most. Right now you can see the stack is full. Therefore, we cannot push this element onto the stack. We cannot insert this element onto stack. It is important to check whether the stack is full in the push function. Let me tell you, there must be some way to actually check whether the stack is full or not. Obviously, there is a requirement for checking this in the push function, right? So here, if we try to push this element 5, then there must be some way to check this, that stack is full. If stack is full, we'll print some message on the screen to indicate that stack is full, right? Here in this push function, we need this piece of code. If top is equal to max minus 1, then print stack overflow and return. What does it mean? If top equal to max minus 1, currently you can see top is 3. And what is max minus 1? Max minus 1 is 3 because max is 4, right? So 4 minus 1 is 3. We know that top is 3 and max minus 1 is also 3. So 3 is equal to 3. Isn't that so? This simply means that stack overflow occurred, which means that stack is full. So we'll simply print this message, stack overflow, and we will simply return back to the caller. Obviously, we can put this return keyword over here even though our function is void. Okay. This simply means we want to return back to the caller because we don't want to execute these 2 lines of code after this piece of code is evaluated. Okay. This is very important step. Now here you can see we are trying to push this element 5 onto stack. Obviously this data variable will receive this value 5. After this we will check this condition. Is top equal to max minus 1? You can see that top is 3 and max minus 1 is also 3. Therefore, we can get inside this if construct, and after this printf function is evaluated, we'll get this message on the screen, stack overflow, right? And then we can return back to the caller. This means we'll return back here. Isn't that simple? I hope the idea is clear to you. This is the complete push function. This push function is capable of storing some value onto stack, and that too at the topmost position. And here we are also checking this condition every time. Is stack full? Is stack full? If stack is full, then we will simply print this message stack overflow. Otherwise, we'll continue to do this. That means we will continue to add elements onto the stack, right? Now let's just try to execute this code in code blocks. Here is the complete code. You can see the capacity of this stack is 4 because max is 4, right? So it can hold 4 elements at most, right? Here you can see I am checking this condition, is top equal to max minus 1. If it is the case, then we'll simply print this message stack overflow. Otherwise, we will increment the top variable by 1 and we'll simply store this particular value, which is indicated by this variable data in this stack ARR top, right? Here in this main function, you can see that push function has been called multiple times. And obviously, if we try to push this element 5, then we'll get this message Stack Overflow. Let's execute this code. You can see this message is printed on the screen, Stack Overflow, right? So this means that our program is working fine. Let me just remove this line. Now let's execute the code. You can see nothing is printed on the screen. Obviously, this means that this code is working fine. As process has returned 0, you can see this, right? So our code is working fine. Here in this stack ARR, we have successfully stored these 4 values, 1, 2, 3 and 4. The topmost element is 4. Remember this, okay? Okay friends, this is it for now. Thank you for watching this presentation.